Hi everyone, UCI Chemistry. Chapter 1, Structure and Bonding. Subchapter 4, Valence Bonding Theory. Have you ever wondered how atoms stick together to form everything around us? Let's talk about it. That's where the valence bond theory comes in handy. It's like a set of rules that helps us understand how atoms form bonds and create molecules. Valence bond theory focuses on the outermost electrons of atoms, called valence electrons. These tiny particles play a crucial role in bonding. Understanding valence bond theory helps us predict the shapes of molecules, their reactivity, and many other chemical properties. Cool, right? Think of it like this. Imagine each atom wants to have a full set of valence electrons, kind of like wanting a complete set of trading cards. They can achieve this by sharing electrons with other atoms. This sharing is what we call a chemical bond. Now let's dive a bit deeper into how this sharing works. When two atoms come close to each other, their valence electrons start to interact. If the conditions are right, a bond forms between them. The valence bond theory says that this bond happens when atomic orbitals, the regions where electrons are most likely to be found, overlap. Imagine two people shaking hands. That overlapping region is where the bond is formed in the world of atoms. This overlap allows the atoms to share their valence electrons and achieve a more stable state. Remember, atoms are constantly moving and vibrating. The valence bond theory helps us visualize how their orbitals overlap and create these strong connections that hold molecules together. We just talked about overlapping orbitals, but what exactly does that mean? Picture two balloons partially pressed together. That overlapping region represents the area where atomic orbitals from different atoms share space. When these orbitals overlap, the electrons from each atom can move freely within that shared region. It's like the electrons are holding hands, strengthening the bond between the atoms. This sharing of electrons is a key concept in covalent bonding, where atoms share electrons to achieve a more stable electron configuration. Covalent bonds are essential for life, as they form the backbone of molecules like water, DNA, and proteins. Sometimes atoms need to rearrange their orbitals to form stronger bonds. It's like they're putting on a new outfit to make a good impression. This rearrangement is called hybridization. Imagine you have a balloon animal kit with different shaped balloons. You can combine and twist these balloons to create new, more complex shapes. Hybridization allows atoms to form bonds in directions they couldn't otherwise. This concept helps explain the shapes of molecules like methane, which has a tetrahedral shape because of the sp3 hybridization of its carbon atom. In essence, hybridization is like atoms getting creative with their orbitals to form the strongest possible bonds. It's a fascinating example of how atoms adapt and optimize themselves to create the incredible diversity of molecules we see in the world. Thanks everyone. Next we talk about sp3 hybrid orbital. Catch you in the next one. Stay with UCI Chemistry.